Good morning, everyone. I am Matt Gropp. I'm a meteorologist here at the National Weather Service in Columbia, South Carolina, just over by the airport. And we wanted to do a run through of kind of what went wrong with the forecast from yesterday, March 16th, with the event that wasn't, with basically a big bust for the severe potential, particularly across eastern Georgia and South Carolina. I like to do these. We do these internally all the time with our events. And I like to do these now. I've done a few for a few of the events we've had over the last few years that didn't work out as expected or worked out well, and kind of just do a recap so people can kind of understand what went wrong from the forecasting standpoint, things we've learned from this event, from a messaging standpoint, feedback we've taken from the public and things like that, to try to improve the forecast going forward in the future. So hopefully people find this useful. It was obviously a pretty high profile event. With a lot of both national and local attention on the forecast and what we expected to happen. And I'll kind of get into that now. So here we go. This was the SPC Day 1 outlook across basically the entire East Coast. Was under pretty high chance for some damaging winds. We were expecting to develop generally across eastern Georgia as the storm kind of transitioned from the day 1 to day 0 time frame. And we were expecting to see that line of damaging winds develop, pushing into our Augusta areas that we cover on the western half of our forecast area, and then kind of going across I-20 and strengthening steadily as it moved to the northeast. You can see here, these are the storm reports, just a couple smattering of storm reports across the eastern Georgia areas and then up through central South Carolina. Notably more reports as you got into the mid-Atlantic, especially with the actual front that came through in the evening. It actually wasn't, a lot of this wasn't with the convection during the afternoon like we expected. It actually was just with the basically the temperature gradient along the front itself. And we saw that here in Columbia. We were gusting into the mid-40s late in the afternoon behind really any of the convection. So let's get into a little bit as to why this event did not work out as expected. So how do busts happen? Well, by definition, you need a highly anomalous setup to get a bust, because highly anomalous setups generally have high-end potential for wind, tornadoes, hail, whatever severe potential it is. These highly anomalous setups can kind of push the envelope from both a climatological standpoint and a model guided standpoint. So the two tools we use as meteorologists to try to come up with a forecast, being climatology and model guidance, generally these highly anomalous events are kind of pushing the limits of both climatology and model guidance. And then what we like to call failure modes, or what can go wrong for a system, and kind of the perspective we look at this is when we mean can go wrong, we mean from a severe standpoint. Obviously, we don't want severe weather to happen. Tornadoes are objectively bad things, but from a forecasting standpoint, when we're forecasting them and they don't happen, that's a failure mode from a forecast standpoint. So these failure modes fall outside of climatology and model guidance as a result. So we have this highly anomalous setup that can lead to these failure modes that are harder to predict. And extreme events like what we had yesterday, from a kind of a physical standpoint, it was an extreme environment, can make these failure modes even more sensitive. And that's basically what happened. So what happened on March 16th is we had an extremely anomalous upper low and jet streak interaction that occurred across the Great Lakes that produced a rapidly deepening low pressure system. This resulted in extreme height falls across our area. So these are those 500 millibar maps you see. As those 500 millibar heights move in and fall, that cools the upper atmosphere, which can prime both the middle and the upper atmosphere for convection. This forcing, those height falls, ahead of the prefrontal trough, ended up producing widespread weak convection, like we saw basically yesterday morning. This neutralized the mid-level lapse rates, created widespread sin, and prevented the severe outbreak for South Carolina and eastern Georgia like we were anticipating. So what happened with this? Well, the models did not handle the prefrontal trough very well. So this convection ahead of the actual squall line we were anticipating was not handled well. The forcing and the height falls were too strong with no cap in place. Again, pushing the envelope from a climatological standpoint and from a model guidance standpoint means the models and our kind of physical intuition is not going to work as well in this type of setup. The HRR model and the HRF in general had generally a low-level dry bias, and this effectively acted as a cap within the forecast themselves. So they didn't predict this prefrontal trough developing and that weaker convection. And this was also compounded by poor forecast timing of when that squall line would actually arrive. It ended up moving several hours earlier and faster than what most of the high-res guidance has. And overall, this led to a thermodynamic environment that was not really falling within any of the model envelope forecasts that we had, and was far too stable for any notable severe weather early on the 16th. So from a lessons learned standpoint, and I'll talk more about kind of exactly what went wrong after this slide here, but from a lessons learned standpoint, busts are going to happen. Forecasting is not a perfect science. Meteorologists know it's just very hard to do sometimes, and these events happen from time to time. Thankfully, they're not the norm, especially with this high end of an event, but busts will happen. We will get things wrong in the future, but we're always going to try to improve to do better with each and every forecast. The failure modes need to be messaged more aggressively is generally a good philosophy to have. Obviously message the high end potential for an event, I think, to make sure people are prepared. That's my own philosophy. But messaging kind of what can go wrong is also important. We, in general, with the National Weather Service, are always going to hedge on the side of a worst case scenario to make sure people are prepared with a severe event, making sure that that's clear, that sometimes we are messaging a worst case scenario. It's nice at the National Weather Service. We don't really gain any benefit by hyping forecasts. Our goal is just public safety and protection of life and property. But generally, we want to have people more prepared for possibly a worst case scenario. So we're going to hedge on the side of a worst case scenario. We could have started downscaling messaging a little faster early in the morning when we realized this probably wasn't going to happen. But even with hindsight, it's hard to know if that would have been helpful or more confusing. But that is a possibility that may have been helpful for some folks. So now I just want to get into a little bit more of the details as to what happened with this event. Let's just look through the radar first. So this is as of 7:22 a.m. So we were expecting at this point still potential for a notable severe weather outbreak across kind of the I-20 corridor in central South Carolina. But we already see this deepening convection across central Georgia that's going to be moving right up I-20. Back to the west, but basically between Augusta and Atlanta, is what we expected to be the squall line with the potential severe winds. And as we see, as we move through time, this weaker, it was still fairly strong, but definitely not severe, weaker convection overspread the I-20 corridor right ahead of this line, which basically stabilized the whole atmosphere ahead of this and led to the lack of severe weather that we expected. You can look through a longer loop. This is all I loaded in for the time being here. But effectively, this is what happened all the way across the I-20 corridor and for much of South Carolina, was this stabilizing weaker convection ahead of what we expected to be the stronger line. So again, if we just take a look here at what the forecast was showing, basically how these forecasts work is the Storm Prediction Center out in Oklahoma, they have their own forecasters, and we have forecasters here in Columbia. And we come up with a collaborative forecast that tries to piece together both our local expertise that we have here in Columbia, since we have people that have worked in just the central South Carolina and eastern Georgia area for 20 years. So we have kind of local expertise, combining it with the national level expertise is the goal when we come up with these forecasts. So it is a combination of local knowledge of the Southeast and Mid-Atlantic, combining with the forecasters out in Norman. So overall, it was a higher level. It was a high level event, expected from both a tornado standpoint, but especially from a wind standpoint, with a moderate risk and a Sig 1 intensity for the potential higher end, 70 plus mile an hour wind gusts. So this is what happened on a mesoscale standpoint. This is 7 a.m. We have our developing convection across central Georgia, and we're starting to see this weaker convection develop within the pool of instability and this ribbon of weak instability that much of this event was based on from a forecasting standpoint. We were expecting this tongue of instability to stretch up the I-20 corridor into central South Carolina, and this is what was basically going to drive the wind and tornado threat. As we move forward in time, we can see this. The blue shading here is our surface convective inhibition, or our surface SIN. And as this convection develops within this weak and sensitive warm sector, it quickly stabilizes across the entire area to the point whereby at 14Z you're seeing between minus 75 and minus 100 SIN, surface-based SIN across the entire area. So that tongue of instability that the entire event was basically reliant on evaporated pretty quick as this moved through. And then you can see there by 15Z, minus 150 SIN across the area, which is far too stable for any severe weather. If we look at a forecast standpoint and what was different in the forecast versus what actually occurred in the mesoanalysis on the last couple slides there, this is a joint probability of greater than 500 surface cape, less than minus 100 surface SIN, so basically less unstable. And the SIG-TOR parameter basically non-zero. So if you look here, this is basically from the HREF. It's got a 12-hour window just showing the chance of that occurring. You can see the HREF had between a 90 and 100% chance of those things occurring at the same time. And again, based on what we saw on the last slide, sorry about the cough, we have between minus 100 and minus 150 SIN right across the I-20 corridor. So that's falling into a 5 to 10% chance of occurring and just falling outside of the model envelope in this case. So this was the big reason this bust happened, was because the guidance just really did not have a good grasp on it. And there was a bit of a mirage in terms of how much instability would occur ahead of it due to both the dry bias that ended up playing out in things like the HRR and the timing and the overall, basically the forcing was too strong that you couldn't keep the warm sector capped and keep that instability close to the surface, and it basically just got wiped out. So that's what went wrong. We'll learn from this. We always do from these types of events. And we hope everyone out there found this informative. And again, let us know if you have any questions or anything like that. Thanks.